Arc fault circuit interrupters, known as AFCIs, and ground fault circuit interrupters, or GFCIs, are both crucial safety devices designed to protect against electrical hazards. AFCIs are specifically designed to detect and interrupt arc faults, which are dangerous electrical discharges that can lead to fires. GFCIs, on the other hand, are designed to detect and interrupt ground faults, which occur when electricity flows through an unintended path to ground, posing a significant risk of electrical shock. While both devices serve to protect against different types of electrical hazards, connecting an AFCI and a GFCI on the same circuit can lead to a problematic situation known as nuisance tripping. Nuisance tripping occurs when the AFCI and GFCI interact in a way that causes them to trip unnecessarily, even when there is no actual fault present. This can be a major inconvenience and can also raise safety concerns, as it can disrupt power to essential equipment or systems. The reason for this interaction lies in the way that AFCIs and GFCIs detect faults. AFCIs detect arc faults by monitoring the current waveform for irregularity. These irregularities can be caused by loose connections, damaged insulation, or other factors that can create an arc. GFCIs detect ground faults by measuring the difference in current between the hot and neutral conductors. If there is a difference, it indicates that current is flowing to ground through an unintended path. When an AFCI and GFCI are connected on the same circuit, the AFCI can sometimes misinterpret the normal leakage current that is present in all electrical circuits as an arc fault. This leakage current is typically very small, but it can be enough to trigger the AFCI, especially if the GFCI is also contributing to the leakage current. The GFCI can contribute to the leakage current because it is designed to detect even very small ground faults. This means that it can be sensitive to leakage current that would not normally be considered a hazard. In a specific application, such as an outdoor receptacle tied into a bedroom circuit in new construction, the potential for nuisance tripping is even greater. Outdoor receptacles are more likely to be exposed to moisture, which can increase the leakage current in the circuit. This, combined with the presence of an AFCI in the bedroom circuit, can create a situation where the GFCI trips frequently, even when there is no actual ground fault. Therefore, it is generally not recommended to use a GFCI receptacle on a circuit that is already protected by an AFCI breaker. The best solution is to install a separate circuit with a GFCI breaker to protect the outdoor receptacle. This will ensure that both the AFCI and GFCI provide proper protection without causing nuisance tripping. When installing a separate circuit for the outdoor receptacle, it is important to follow all applicable electrical codes and regulations. This includes using the correct size wire, conduit, and fittings, as well as properly grounding the receptacle. It is also important to test the GFCI receptacle after installation to ensure that it is working properly. To further elaborate on AFCIs, it's important to understand their different types and functionalities. There are branch or feeder AFCIs which are installed in the electrical panel to protect the entire branch circuit. Combination AFCIs offer both branch and feeder protection and also protect against series arcs, which can occur within cords or appliances. The NEC, or National Electrical Code, mandates AFCI protection in many areas of a home, including bedrooms, living rooms, dining rooms, and family rooms, to reduce the risk of electrical fires. Now let's delve deeper into GFCIs. GFCIs work by monitoring the current flowing to and from an appliance or device. If there's a difference of as little as 5 milliamps between the outgoing and incoming current, the GFCI will trip, cutting off the power in a fraction of a second. This rapid response is crucial in preventing electrical shock. GFCIs are commonly found in areas where water is present, such as bathrooms, kitchens, laundry rooms, and outdoor locations. The NEC also requires GFCI protection for receptacles in these areas. When dealing with electrical installations, it's crucial to understand the applicable codes and standards. The NEC is the most widely adopted electrical code in the United States, and it provides detailed requirements for safe electrical installations. It's important to consult the latest edition of the NEC and any local amendments to ensure compliance. In addition to AFCIs and GFCIs, there are other types of protective devices that can be used in electrical systems. These include surge protective devices, or SPDs, which protect against voltage surges caused by lightning or other events, and overcurrent protective devices, such as circuit breakers and fuses, which protect against overloads and short circuits. When designing an electrical system, it's important to consider all of the potential hazards and to select the appropriate protective devices to mitigate those hazards. This includes considering the type of occupancy, the type of equipment being used, and the environmental conditions. A well-designed and properly installed electrical system is essential for ensuring the safety of people and property. Furthermore, understanding the nuances of electrical grounding is paramount. Grounding provides a low-impedance path for fault current to return to the source, allowing the overcurrent protective device to trip and clear the fault. There are different types of grounding systems, such as grounded and ungrounded systems, each with its own advantages and disadvantages. The NEC specifies the requirements for grounding and bonding electrical systems. Bonding is the process of connecting all metallic parts of an electrical system together to create a common ground potential. This helps to prevent voltage differences between different parts of the system, which can be a shock hazard. Regular inspection and testing of electrical systems is essential for ensuring their continued safety and reliability. This includes visual inspections to identify any signs of damage or deterioration, as well as electrical testing to verify the proper functioning of protective devices and the integrity of the grounding system. Any deficiencies that are identified during inspection or testing should be promptly corrected by a qualified electrician. Electrical safety is a shared responsibility. Homeowners, building owners, and electrical professionals all have a role to play in ensuring the safe operation of electrical systems. By understanding the principles of electrical safety and following safe work practices, we can all help to prevent electrical accidents and injuries. Regarding the specific scenario of an outdoor receptacle, consider the implications of different types of outdoor environments. A receptacle located in a damp or wet location, as defined by the NEC, requires specific types of enclosures and wiring methods to prevent water from entering the electrical system. Weatherproof receptacles and covers are designed to protect against rain, snow, and other environmental conditions. In addition to GFCI protection, outdoor receptacles should also be protected by a weatherproof enclosure when not in use. This will help to prevent moisture and debris from entering the receptacle, which can cause corrosion and other problems. When selecting an outdoor receptacle, it's important to choose one that is rated for the environment in which it will be used. Receptacles are typically rated for either damp or wet locations, and it's important to choose the correct rating to ensure that the receptacle will provide adequate protection. In addition to the receptacle itself, the wiring method used to connect the receptacle should also be appropriate for the environment. For example, underground wiring should be installed in conduit to protect it from damage. Above-ground wiring should be supported properly to prevent it from sagging or coming into contact with other objects. When working with electricity outdoors, it's important to take extra precautions to protect against electrical shock. This includes wearing rubber-soled shoes, avoiding contact with water, and using insulated tools. It's also important to be aware of the location of overhead power lines and to avoid contact with them. If you are not comfortable working with electricity, it's best to hire a qualified electrician to do the work. They have the training and experience necessary to safely install and maintain electrical systems. Remember that electrical work can be dangerous, and it's important to take all necessary precautions to protect yourself and others. Let's consider a scenario where you have an existing outdoor receptacle that is not GFCI protected. In this case, you can replace the existing receptacle with a GFCI receptacle. However, it's important to make sure that the circuit is properly grounded before installing the GFCI receptacle. If the circuit is not grounded, the GFCI receptacle will not work properly. You can also install a GFCI breaker in the electrical panel to protect the entire circuit that serves the outdoor receptacle. This is a good option if you have multiple outdoor receptacles on the same circuit. When installing a GFCI breaker, it's important to follow the manufacturer's instructions carefully. Be sure to test the GFCI breaker after installation to ensure that it is working properly. Another important aspect of electrical safety is proper labeling. All electrical panels and circuits should be clearly labeled to indicate their purpose. This will help you to quickly identify the correct circuit when you need to turn off the power for maintenance or repairs. Labels should be durable and easy to read. They should also be updated whenever changes are made to the electrical system. In addition to labeling, it's also important to keep electrical panels and equipment clear of obstructions. This will allow you to access the equipment quickly in case of an emergency. Don't store anything in front of electrical panels or equipment. Keep the area around electrical equipment clean and dry. Preventing electrical hazards is an ongoing process. It requires vigilance and attention to detail. By following safe work practices, maintaining electrical equipment properly, and being aware of potential hazards, we can all help to create a safer environment. Think about arc fault circuit interrupters a bit more. Arc faults can occur for a variety of reasons, including damaged insulation, loose connections, and faulty appliances. They can be very difficult to detect, as they often don't produce enough current to trip a standard circuit breaker. AFCIs are designed to detect these low-level arc faults and to trip the circuit before a fire can start. There are two main types of AFCIs: branch feeder AFCIs and combination AFCIs. Branch feeder AFCIs protect against arc faults in the branch circuit wiring, while combination AFCIs protect against arc faults in both the branch circuit wiring and the appliance cords. The NEC requires AFCI protection in many areas of the home, including bedrooms, living rooms, dining rooms, and family rooms. Combination AFCIs are generally recommended, as they provide the most comprehensive protection. When installing an AFCI, it's important to follow the manufacturer's instructions carefully. Be sure to test the AFCI after installation to ensure that it is working properly. AFCIs are a valuable safety device that can help to prevent electrical fires. Now let's discuss ground fault circuit interrupters in more detail. GFCIs work by monitoring the current flowing to and from an appliance or device. If there is a difference of as little as 5 mA between the outgoing and incoming current, the GFCI will trip, cutting off the power in a fraction of a second. This rapid response is crucial in preventing electrical shock. GFCIs are commonly found in areas where water is present, such as bathrooms, kitchens, laundry rooms, and outdoor locations. The NEC also requires GFCI protection for receptacles in these areas. There are two main types of GFCIs: receptacle GFCIs and breaker GFCIs. Receptacle GFCIs are installed in place of standard receptacles, while breaker GFCIs are installed in the electrical panel. Both types of GFCIs provide the same level of protection. When installing a GFCI, it's important to follow the manufacturer's instructions carefully. Be sure to test the GFCI after installation to ensure that it is working properly. GFCIs are a valuable safety device that can help to prevent electrical shock. Let's spend a moment to address common misconceptions about AFCIs and GFCIs. Firstly, some people believe that AFCIs and GFCIs are interchangeable, but this is not the case. AFCIs protect against arc faults, while GFCIs protect against ground faults. They serve different purposes and protect against different types of electrical hazards. Secondly, some people believe that AFCIs and GFCIs are not necessary if the electrical system is properly installed, but this is also not true. Even in a properly installed electrical system, arc faults and ground faults can still occur due to damaged wiring, faulty appliances, or other factors. AFCIs and GFCIs provide an extra layer of protection that can help to prevent electrical fires and shocks. Thirdly, some people believe that AFCIs and GFCIs are too sensitive and that they trip too easily, but this is generally not the case. AFCIs and GFCIs are designed to trip only when there is a genuine electrical hazard. If an AFCI or GFCI is tripping frequently, it's important to investigate the cause of the tripping and to correct any underlying problems. Electrical safety is not just about installing the right equipment, it's also about using electricity safely. Here are a few tips for using electricity safely. Never use electrical appliances near water. Keep electrical cords and appliances in good condition. Don't overload electrical outlets or circuits. Use extension cords safely. Have your electrical system inspected regularly by a qualified electrician. By following these tips, you can help to prevent electrical accidents and injuries. Now, let's consider the scenario where you are experiencing nuisance tripping with an AFCI and GFCI on the same circuit. In this case, the first step is to identify the source of the tripping. You can do this by systematically disconnecting appliances and devices from the circuit to see if the tripping stops. If you are able to identify a particular appliance or device that is causing the tripping, you should have it repaired or replaced. If you are not able to identify the source of the tripping, you may need to consult with a qualified electrician. They can use specialized equipment to test the circuit and to identify any underlying problems. In some cases, the nuisance tripping may be caused by a faulty AFCI or GFCI. In this case, the device will need to be replaced. Remember, it is recommended to separate AFCI and GFCI circuits to avoid nuisance tripping. When dealing with electrical issues, it's always best to err on the side of caution. If you are not comfortable working with electricity, or if you are unsure about how to proceed, it's best to hire a qualified electrician to do the work. They have the training and experience necessary to safely diagnose and repair electrical problems. There are a few other considerations when dealing with outdoor receptacles. For example, if the receptacle is located in a high-traffic area, it may be necessary to protect it from physical damage. This can be done by installing a bollard or other protective barrier around the receptacle. It's also important to consider the potential for vandalism. If the receptacle is located in an area where it is likely to be vandalized, it may be necessary to install a tamper-resistant receptacle or to enclose the receptacle in a locked box. Remember, the goal is to provide a safe and reliable source of electricity for outdoor use. Now we will talk about electrical codes. Electrical codes are a set of rules and regulations that govern the safe installation and maintenance of electrical systems. These codes are designed to protect people and property from electrical hazards. The most widely adopted electrical code in the United States is the National Electrical Code, or NEC. The NEC is published by the National Fire Protection Association, or NFPA. The NEC is updated every 3 years to reflect changes in technology and best practices. It's important to consult the latest edition of the NEC and any local amendments to ensure compliance with all applicable electrical codes. Electrical codes cover a wide range of topics, including wiring methods, grounding, overcurrent protection, and equipment installation. They also address specific requirements for different types of occupancies, such as residential, commercial, and industrial buildings. Compliance with electrical codes is essential for ensuring the safety of electrical systems. Failure to comply with electrical codes can result in fines, penalties, and even legal liability. It can also increase the risk of electrical fires, shocks, and other hazards. So, with our main question, is it safe to use a GFCI receptacle on a circuit protected with an arc fault breaker? The answer is no. And the outdoor receptacle tied into the bedroom circuit on new construction should install a separate circuit with a GFCI breaker to protect the outdoor receptacle.